Hey everyone, welcome back to MindMaster. This question is based on Class 11 Chemistry, specifically Chapter 2, Question 2.18. Let's break it down step by step. Our problem has two parts. Calculate the energy required to shift the electron from the first Bohr orbit to the fifth Bohr orbit. Calculate the wavelength of light emitted when the electron returns to the ground state. Part I. Let's start with the first part. Calculating the energy required to shift the electron from the first Bohr orbit to the fifth Bohr orbit. The energy of an electron in the nth orbit of a hydrogen atom is given by this formula, n versus n2 were 13.6 eV. But we have the ground state energy in ergs. We need to convert it to joules. Given ground state energy is 2.1810 in 11 ergs. Since we're in erg 10 nor 7 joules, E1 nor 2, 18 10, 11 erg square 10 nor 7 2, 18 10, 18 joules. Next, we calculate the energy of the electron in the fifth orbit, N5. Using the formula again, E5 or 522.1810, 18 joules, Freus 8, 7210 or 20 joules. Now, the energy required to shift the electron is the difference between these two energies. DE5, E1 star 872x10, 20, 218 scan 18 2 0928x10 18 joules. The energy required to shift the electron from the first to the fifth orbit is 2.09 18 joules. Part T. Next, let's calculate the wavelength of the light emitted when the electron returns to the ground state. First, we find the energy of the photon emitted during this transition. The energy of the photon is the energy difference between the first orbit and the fifth orbit. The E1, E5, 2.1810, 18 + 8, 72x10, 20, 2, 2672 10, 18 joules. Now we use this energy to find the wavelength of the emitted light using the formula. ELLHC, where h is Planck's constant, 6.62610 or 34 J, and CCC is the speed of light, 3x10 8 MES. Rearranging the formula to solve for L, EHC, 2.2672x10, 18 6.626 13, 34 to 3x10 8. Doing the math, we get L 2.2672x10 is 18, 19878x10 so 25, 8.7 10 8 meters. Converting to nanometers, we get 87.7 nanometer. So the wavelength of the light emitted is 87.7 nanometer.